Hey everyone, it's TJ with Avidine. In the following brief video, we're going to be discussing some tips and tricks for troubleshooting ADSB traffic interfaces with the IFD. As always, everything in the following video is for reference use only. For FAA approved data, please refer to the IFD installation manual. Make sure you're looking at the latest rev. So, to jump right in, depending on what traffic device it is, the traffic data is either going to be coming across via airing 429 or RS-232. So definitely want to take the time to discuss these two particular pages here in maintenance mode. If you boot the IFD into maintenance mode and you go over here to the status tab and then cycle this info button in the lower left hand corner until it says info A429 or info RS232, depending on what type of interface it is we're looking at. And what this is this is actually going to show you, data coming across that port. This is the airing 429 or RS232 port monitor. So it might tell us, exactly what's going on if we see a message that says something to the effect of traffic device not communicating. That's a pretty good indication that there's just no data coming in on the port we're expecting it to. So this is a really handy place to go look and see if you've got any data coming across at all, or perhaps something got miswired, mispinned, or we've configured the wrong port. I've seen that happen before as well. So keep those in your back pocket. That's a very helpful place in troubleshooting these types of problems. This next one is going to be kind of dependent upon if your ADSB data stream is carrying both traffic and weather, in like maybe a capstone traffic and weather type protocol. Here's another place you can go take a look just to double verify that the data stream is coming across. What you should see if you're getting the ADSB weather is under this service level, it should say ADSB WX. Again, not real useful in troubleshooting an airing 429 connection, but if you're sharing the same data stream for traffic and weather, and you've got weather data here, then there's no good reason you shouldn't also have traffic unless you're missing some other component or some piece to that. And we'll get into some of those things as well. This one we get phone calls about quite often. The NoTISB message, and this will pop up on the map page. And all this means is that whatever ADSB information you're receiving at the time, it is not including your tail number as part of that traffic solution. Meaning that the ground station does not currently see you. That's probably the easiest way to interpret that. If you're on the ground, sitting in the hangar, even out on the ramp most of the time, I would expect to see this. Not a big deal. If you're out flying, doing a test flight or what have you, and you've got this NoTISB message and it never goes away, it's there constantly, it's a pretty good indication that something's configured incorrectly. Maybe an ICAO code missing somewhere or off by a digit, that kind of thing. But just seeing that on the ground, essentially all that means is that the ground station doesn't see you right now. So expect to see that. It's not uncommon. No reason to worry too much about that. Something else to consider, and something else that's definitely worth thinking about when we're troubleshooting these ADSB traffic interfaces. It helps a little bit to understand first what group you're in here, right? So some of these are ADSB standalone receivers, like the Skytrax 100B, Free Flight Ranger. There are a handful of others that are like that as well, just standalone receivers, right? And then others where the receiver is built in to your ADSB out. So, it would be a transponder, single box solution type stuff. So the way we're going to go about troubleshooting those might be a little bit differently, depending on what the problem is. But it's pretty important to kind of get your head around, what does my installation look like, and what can affect those things, right? So for instance, if you've got an ADSB standalone receiver and you've got an issue where it's ghosting, basically it's displaying your own aircraft as a target right on top of you. What that tells us is the ADSB ground station is spitting out all of the targets, which we already know that's how they work. Those targets include you. Since there is no interrogation or reply, there's no suppression circuit to kind of look for. There's nothing like that. What we need to understand is how that suppression takes place. How does the airplane know to eliminate your aircraft as a target? And the way that it does that is all of these standalone receivers have a configuration setting for the ICAO code. Now, that ICAO code has to match what the ICAO code is set for in your transponder or your ADSB out device. If those two things don't match, then you're going to see yourself as a target. Now, it might be the ICAO code configuration on the receiver, on the standalone ADSB receiver itself. It might be the ICAO code on the transponder. But if you were to call us in tech support and say, hey, I've got a Skytrax 100B and I'm seeing myself as a target, the very first thing we're going to have you do is go double verify your ICAO codes in both the Skytrax 100B and in whatever your transponder ADSB outsource is. Okay? Now, as you can see, this isn't really a squawk that comes up with a single box solution, because you set the ICAO code once and that's it, you're done. There's not two different pieces to it that have to agree. So I've never seen a single box solution do ghosting like this. If you ever see one, by all means give me a ring. I would be very interested to see what the cause of that would be, because I've never seen that before. Okay. It's also really important to understand, even with a single box solution, what the different frequencies are and where they apply and how they apply. Right? So if we're looking at ADSB out and we're talking 978 or UAT frequency, that's the one that they specified as for aircraft below 18,000 feet. For 1090 ADSB out, there is no altitude restriction. But understand that those altitude restrictions apply to ADSB out, like your airplane squawking to the ground station. ADSB in, you can have a 978 UAT receiver on a jet. We installed one in a Citation not that long ago. So that's not uncommon to see that. And that'll work just fine. They just can't use 978 UAT for ADSB out. So let's talk about ADSB in a little bit. If we're talking about 978 UAT for ADSB in, that is going to give you ADSB traffic and FISB weather, but only on the 978 megahertz frequency. Okay? You don't have to use both. You can use, a GEL69 for weather and still bring in the ADSB traffic, or if you've got an active traffic system on board and you don't want to mess with ADSB traffic, you can do just the FISB weather. That's fine. But understand that that's coming across on a 978 frequency if you've got a UAT in. For a 1090 in, that's going to give you ADSB traffic only, and it's only going to be on the 1090 megahertz frequency. If you've got a dual band receiver, something that you can set up dual band receive, where it's listening for both the 978 and the 1090, you're going to get 978 UAT traffic, which means traffic from other aircraft in the vicinity that are using a 978 UAT for ADSB out, and FISB weather on the 978 frequency. And you'll also receive 1090 traffic on the 1090 frequency, meaning airplanes that are out there flying around that are using 1090 for their ADSB out. The important thing to understand here is with a dual band receiver, If you're the only person talking to the ground station, you are not going to trigger an ADSR, because the ground station understands that you're listening for 978 traffic on 978 as well as 1090 traffic on 1090. This can become problematic if you've only got a single band receiver. So let's talk about that a little bit. ADSR. What is ADSR? ADSR is the rebroadcast. So for instance, if I've got an aircraft out there that is a 978 out, but I've only got a 1090 receiver on my aircraft, I'm not going to see him air to air because I'm not listening on the same frequency he's squawking. But he's sending his information to the ground station on 978. My transponder should also be telling, or my ADSB outsource, I guess I should say, most of the time it's transponder, should be telling the ground station, hey, I've got a 1090 receiver on board my airplane. I don't have a 978, I've got a 1090. The ground station sees that and says, okay, well, let me hook you up then. And they're going to take that 978 target, they're going to roll it over onto the 1090 frequency and then rebroadcast that out. Send that back out for me. Okay? And same thing goes vice versa. If I've only got a 978 receiver on board, then these other 1090 targets out there, I'm not going to see air to air. So what that means is, they're going to be squawking 1090 to the ground station, but I'm telling the ground station I've only got a 978 on board. So the ground station then rolls that over, a 1090 target onto the 978 frequency, and rebroadcasts. Where this becomes a little bit of a strange beast is essentially if I'm the one telling the ground station what to send out and I'm misconfigured. So let's just look at what that looks like. Let's say I've got an FDL 978 or some other UAT receiver, and that's it. It's a 978 UAT receiver. And my transponder is configured to tell the ground station that I have both a 1090 receiver and a 978 receiver. Well, if I do that, I'm telling the ground station, don't worry about ADSR. You don't need to worry about the rebroadcast. Send me the 978 targets on 978. Send me the 1090 targets on 1090. But if I've only got a 978 receiver on board, the end result of that is going to be I'm going to have a very incomplete traffic picture. Make sense? The last piece to this that makes this even more difficult to get your head around is that if someone else is in the vicinity of my airplane, even if I'm configured wrong, the way we just spoke about, if someone else has a 978 UAT receiver and they're in my vicinity and they're configured correctly, they're going to tell the ground station, hey, send me the ADSR stuff because I've only got 978 on board. The ground station will go ahead and send out the ADSR information, and all of a sudden my complete traffic picture comes to life. But it's not because everything in my airplane is perfect. It's because someone else triggered the ground station for the ADSR piece to come through. So the end result of this is we start seeing these very intermittent type squawks, right? Sometimes my traffic works great, other times I get nothing. It's very spotty. Sometimes I only have, half the targets, and then other times I've got all of them. Whenever you get a squawk like that, that's one of these intermittent kind of things with this ADSB traffic, look very, very closely at how we have whatever our ADSB out device is configured. Because if we're telling the ground station to send us the wrong information, that's why we're receiving the wrong information. Okay? So, some stuff to keep in mind. This next page is just an example of one set of places where you might go set this type of thing. But pretty much every ADSB out system out there has a place to set this. This is an example with an AXP322, our remote transponder. This is where you would set that. But even the panel mount transponders, there's a setting in there where you tell the ground stations, you tell your transponder to squawk out what type of receiver you have on board. Okay? That's how it knows. That's how the ground station knows what to send you. Like I say, what this usually results in is it results in some variation of I see part of the traffic but not all of the traffic, or I see all of the traffic some of the time but never all of the traffic all of the time. Okay. Someone else is within your hockey puck triggering a ground station and send ADSR, you're going to see a complete picture. But if you're all alone out there and you're triggering the ground station and you're set up incorrectly, you're not going to receive the 978 targets, or you're not going to receive the 1090 targets rather, because you've told the ground station, send me 1090 on 1090, and you don't have the 1090 receiver on board. If you guys have any questions about this, feel free to shoot us an email over in tech support. I'd be glad to go further down the rabbit hole here. It gets pretty complicated pretty quickly, but the gist of it is, make sure your ADSB out is configured correctly for what you have on board the airplane. Something else we see quite a bit, traffic sensor fault. So, and this is just an example, but you'll see this message right here will pop up in the lower right hand corner of the IFD and say there's a traffic sensor fault. And a lot of times what we'll get is an email, from you guys out there that says something to the effect of, hey, I've got a traffic sensor fault on the IFD. Well, there's a bunch of stuff that can cause this, so that's not very helpful. If you see a traffic sensor fault on the IFD, toggle over to the Alert tab and go look at what this full message is, because that makes a lot more sense all of a sudden, right? Traffic sensor fault, okay, we go to the Alerts tab. The Alerts tab gives us the long message. It says traffic sensor altitude unavailable. Alright. Well, now at least we know where to go look, and it makes sense, right? We know what's going on. It's important to remember that all of these ADSB receivers need to have an altitude source. The IFD cannot serve as the altitude source for these things, so they'll need their own dedicated altitude source. We've even gotten phone calls before where an Aspen system was the altitude source for an FDL 978, and what ended up happening is, and we've all done it, I know I've done it, you're in there testing out the system, but you figure, I'm just going to do a quick check, so I'm going to leave it on battery power, and I don't need to turn the Aspen on since it's got its own little dedicated switch there. I'll leave it off. So that's something to think about, something to look for. Okay, if your ADSB receiver is receiving altitude from an EFIS system or what have you, that EFIS system needs to be on and powered up, otherwise you're going to see faults like this. So think about it more from a big picture when it comes to testing these things out or troubleshooting, and don't overlook some of the obvious stuff. Another one we get a lot of phone calls about is this one right here, ADSR ADSB unavailable. What that means is that your aircraft is not in view of the ADSB ground station for at least 40 seconds. Or that the ADSB ground station is in view and is specifically telling you that your ADSB out signal is non-compliant. So, let's think about that for a minute. That's a pretty broad range of things to cause this, right? But it's fairly simple if we start applying just a little bit of troubleshooting logic. Usually what this looks like is a pilot will show back up in your shop and say, hey, I got this ADSR ADSB unavailable message. What does it mean? The follow-up question to that is, what phase of flight were you in? And consider, maybe where you're located geographically as well. So for instance, if I were doing a lot of flying around Colorado, I would totally expect to see this message on departure and approach, because there are going to be times where there's a mountain between me and the ground station. So that may not necessarily mean anything is wrong or anything is bad or anything else. It's just letting you know, hey, the ground station doesn't see you. If I'm doing the same flight profile in, I don't know, let's say Wichita, Kansas, that could be problematic, right? It might be a clue that something's wrong, because there's not much there that's going to block the ground station's view of me. Unless I'm just geographically far enough away from a ground station that the curvature of the earth is letting it fall off, okay? Ground station stuff is line of sight, so it's important to keep that in mind. But this is definitely one of those things that if you see it on departure and approach, I wouldn't make too much out of it, especially if you're in a mountainous region, okay? If it's there continually, it's a really good indication that something else is wrong. Your ADSB out stuff is non-compliant for some reason or another, okay? So might be worth taking a look at the configuration settings and all of that good jazz at that point. Track degraded. We get phone calls about this one quite a bit as well. So with the traffic thumbnail set up on the IFD, you may see track degraded. What it's telling you is the angular placement of the intruders in the traffic thumbnail is not necessarily within 5 degrees of the nose of the airplane. If your aircraft does not have a heading source connected to the IFD, then the only way the IFD knows where the nose of your aircraft is based off of a GPS track. If you are on the ground and not moving in any general direction at all, then there's not really multiple points to track to figure out what direction you're going. So if you guys see this on the ground and the airplane's not moving, I wouldn't sweat it at all. I would totally expect to see that. If you see this during flight, however, that's a completely different scenario. When the aircraft is in flight, we shouldn't see track degraded. That might be an indication we've got a GPS problem, okay? But on the ground, aircraft not moving, we see this message, not a big deal. Move on. Kind of the same thing with this one. This one might pop up in the traffic thumbnail as well, and it's saying position degraded. Not that uncommon on the ground still, at least until a good GPS signal is acquired. What we usually find is when we get a phone call about this one and the aircraft is on the ground, it's because the aircraft is setting between, T-hangers, that kind of thing, where there's something blocking half the sky from a good GPS signal, and you'll get a position degraded type CAS message. And again, not that uncommon on the ground. If you're out there flying around and you see this, totally different set of problems. Then we may have a GPS problem and we need to take a look at it, okay? ADSB degraded. So what this is telling us is that the receiver has not yet gotten a good enough GPS lock to update its internal clock, or there is a problem with the ADSB receiver's GPS position. So, if we're on the ground and the IFD is not locked on the GPS yet, I would totally expect to see this along with position degraded, right? Those things kind of go hand in hand, especially if the IFD is the GPS source for whatever your ADSB receiver is. A couple other things just to try to wrap this thing up. This has gone on a little longer than I intended to, but hopefully you've taken some good information out of this. Whenever it's possible, use the same altitude source to provide altitude to the IFD as well as the traffic device. That can save you a lot of heartache and potential altitude loop type scenarios, especially when we're starting to dabble with the ADSB stuff. Let me back up one real quick. This also makes troubleshooting altitude problems a little bit easier. If you've got the same source tied to multiple places in the airplane, it gives you a place you can double reference and double check. You can always go to the IFD and see if the IFD is receiving good altitude if you think your traffic device is not. IFDs will cross-sync ADSB traffic and weather. There's no need to wire both IFDs in a dual installation. I'm going to say that again. Crosssync will cross-sync ADSB traffic and weather. There's no reason to wire both units. Okay. If for some reason you've got a customer out there that is diehard about wiring both units, go ahead and do it. It's fine. But I would recommend do not use the capstone high-speed protocol, because what can end up happening is if we're running high speed, that's 115-200 BPS, and cross-syncing at 115-200 BPS and receiving at 115-200 BPS, it's a lot going on. It can really start to tax the processor a little bit and slow some of the other things down that the IFD's needing that resource to do. So again, if you're going to wire to both and have cross-sync on, use the slower baud rate. The last little bit I'm going to leave you guys with is when you're troubleshooting an ADSB traffic problem, it's always a good idea to request a fresh ADSB report from the FAA. It can a lot of times tell you exactly where the problem lies. Typically, a pilot reporting that the traffic's not quite working correctly is really just a symptom of an underlying problem with what's configured for your ADSB out. A lot of times that's the case. What I would probably recommend is if you guys get a phone call from one of your customers saying, hey, my traffic picture's not quite correct, or something, something funky's going on with my traffic, go ahead and ask him when the last time he flew was and run an ADSB report for him. Because a lot of times you'll find your problem right there. That ADSB report will tell you how you're set up on your transponder for your ADSB receiver, 1090 or 978 like we talked about. It'll tell us your GPS status throughout that entire flight, all of that good information. So that's a good place to start. Anyway, as always, thanks for watching. If you guys have any questions, don't hesitate to contact us, and we'll see you in the next video.